This is the Murray State University 2020 Robot in 3 Days mechanical video. So we'll start with a quick overview of the robot. Okay, so as an overview, first we have right now currently this robot can intake the balls, carry it up the tower, go to the shooter wheel at the top, and it can shoot it into the upper high goal and the front goal. We don't have it dialed in yet to shoot into the rear goal, but we do have that capability later on. So we will just go. We'll go through this the way the ball will travel. First off, we will start by where we intake the ball. It starts in the upright position at the beginning of the match to be inside the frame perimeter, and then at the beginning of the match it rocks forward and stays down. What this does, this allows us to pick up the ball and it moves our center of gravity forward to about the center of our robot. So then we use a 1.5-inch PVC pipe that runs off of a motor and a half-inch hex shaft with Andy Mark tread on it to intake the ball and bounce into the corral. The motor that we use is just a small little bag motor or mini sim right here. It is run off of a Vex Versoplanetary gearbox with a 5-to-1 gear ratio, and then our pulleys are a 28-tooth to a 14-tooth pulley that run that power the rest of it. And so for all this is also constructed out of 2x1 aluminum tubing with let's see if I can get you a good view there, with 1/8-inch sidewall. That is all 6061 T6 aluminum. All of our corral pieces are made out of polycarbonate panels that give us enough flexibility and rigidity to corral the ball. Next, in the next stage, we have it in our tower. The tower is currently it's constructed using the Andy Mark Raptor Track tank drive system that we put at a specific angle in order to be able to get the ball where we need it to be. This angle was mostly determined by having enough room to corral the ball in the front and then have it to where we can shoot off of the back and with a minimal amount of distance that we need to do while not having to make the ball climb vertically. The whole tower that you can see here is all made out of the same 2x1 tubing as before, as well as 1x1, all 6061 aluminum T6. It is also put together constructing these Andy Mark gussets. And finally, as you can see, it comes up here and falls into the little ball corral. If you notice, it was highly compressed. We have about a 6-inch gap here, which allows for 1-inch compression throughout most of the entire system. That gives us plenty of compression and traction to allow our ball to travel up safely without slippage. Before I go to the shooter, I'm going to come back here to the track. We have another bag motor here with about a 30-to-1 gear ratio here, Versoplanetary ratio, as well as a 1-to-1 tension belt right here to allow our motor to come down a little further. Now that we get to our shooter, for a gearbox, we have the Vex Flyer gearbox. Right now we just have a 1-to-1 ratio, or Andy Mark, my apologies, not Vex. This is an Andy Mark gearbox with a regular size sim motor, along with the Andy Mark 4-inch compliant wheels. These 4-inch compliant wheels, once they get up to RPM, expand to 4.4 inches. In doing so, this gives us about 1.5 inches of compression back here with our hood, which allows us to aim the ball in the proper trajectory that we wanted as it shoots. In order to get from the nestled component up to the actual shooter wheels, we have just a very small diameter pneumatic piston, along with a 3D printed little cup for it to hold, and it extends and the ball is grabbed and the ball is sent flying. One of the final components that we have here is we have a little snowblower motor that is just mounted direct drive to an 8-inch wheel. That all this does is we drive up under the power panel, and this will spin it to where whatever, and we can also spin it forwards and backwards in order to control where in order to spin it the correct number of times, as well as to land on the correct color. We do not currently have a climbing mechanism on this. However, in a separate video, we will show what climber we were going to use and where we were going to attach it. It would be attached almost right here because with the arm extended downward, our center of gravity puts us right here where we can balance out. As for drivetrain, we used a Mecanum drive. We have 4 wheels with 4-inch Mecanum wheels, or 6-inch Mecanum wheels, and 4 motors, so 1 per each wheel. They are regular sim motors. They have a 12 to 72 tooth gear at the front with a 28 to 14 tooth belt in the back, which gives us a total gear ratio of about 1 to 8 for all. And since they're Mecanum, it allows for the strafing. And that's our robot.